Good evening, everyone. My name is Sam Nasser, and this is the September meeting of the Cleveland C# VB.NET user group. For those of you that are joining us for the first time, welcome. Glad to have you. We meet once a month, every month, typically on the fourth Thursday, and meetings are free of charge and open to the public, and we cover a variety of topics related to .NET. Meeting information can be found on the Meetup site, as you see the link there below, and more than likely, if you were able to RSVP for this meeting, you obviously know where that site is. Just a couple announcements. First, we'd like to give a big thank you to our sponsors that have been supporting us for many years in a variety of ways. Granted, although we are in quarantine now and we've gone virtual, but we'd like to thank Tech Systems for sponsoring the space where we had met before and probably will meet after quarantine, whenever that will be. iNeedle for sponsoring the drinks and the pizza. PostSharp for sponsoring some of the prizes that we had received, and the web hosting courtesy of NIS Technologies. Some general information. Basically, the only valid point on this slide is that participation is highly encouraged. Feel free to jump in any point in time with questions, either verbally or type them in the chat window, and then we'll handle the chat window questions every so often. Also, please keep yourself on mute unless you're jumping in with a question. And tonight's feature presentation is Mads Torgersen from Microsoft, based out of Seattle, and he is going to be discussing the future of C#. Mads is the lead designer of the C# programming language, and he's the program manager at Microsoft. From what he had told me earlier, he's been on the team for 15 years. And he's the only one that he remembers that has been on the team that long. So with that, I will turn over to Mads.
Thank you. Great to be here. I am already echoing in somebody's living room. Let's see. So I will press the presenter thingy and get that screen up and going. Are you all getting this? I'm getting it, so I'm just
yes.
Great.
Yes.
Good. Not that it's hopefully the least exciting, second least exciting slide that I have. Well, just a little correction. I'm not the program manager at Microsoft. We have hundreds of thousands of them, but I am one of them. But yeah, more to today's point. I am the current lead designer of the language. So that means I'm the only one who gets paid primarily to make sure we put something into C# in every release. Lots of people help with that, but I'm the one who gets spoken to sternly if it doesn't happen. So in order to do that better, at some point a good 3 years ago, we decided to take the principles we have around how we go about evolving a language like C# and put them into text. So we wrote a blog post that had C#, VB, and F# in there, and the language strategy for each. And you can for each of them. You can see the URL here in the slide. I hope it doesn't cut off. No, it doesn't look like it cuts off. Okay, there you are. So if you want to read more about it, you can read it there. But I'll summarize sort of the key main points here. Which are threefold. One of them is we are in C#. We are eager to evolve the language in so that it at any given time it keeps up with the changing demands of the developer world. So if and when something changes and more other things become important for developers to do, and that becomes awkward in C#, well, we will move the language along. And even also as the language landscape evolves and nifty features pop up elsewhere, we are very happy to steal them. And I know that that other languages return the favor as well, so we have no qualms about that. So there's a lot of let's just say mutual inspiration in the programming language community, and we definitely participate in that. So there's a lot of things that we get from elsewhere, or the idea comes from elsewhere, and we work hard to massage it into a shape where it fits well into C#, where it can merge into the coherent whole that we try to keep C# and sort of be in stay with the spirit of the language, if you will. But we will take in many things, and occasionally we're the ones who innovate and who come up with new ways of doing things that help the industry turn a corner, and other people pick that up. Like with async await, I think it's fair to say that that was a model that started with C# and other languages are picking up because it works fairly well. So JavaScript developers now have to deal with that as well. I hear they didn't do so well with cancellation as we did, so they struggled with that a little. But hey, maybe they should have consulted us. Is somebody trying to ask a question, or is it just chatter? Okay, I'll assume it's just chatter. Actually, one thing you can say about this is that you sort of have to, when you do a programming language, you can't really, unless you were like Swift in the beginning years, you can't really break people all the time. You can't take things out and people's code will be broken. Somehow they got away with it, but even they are sort of coming out of that mode because it gets kind of exhausting if your code is broken every year. So we don't want to do that. We value backwards compatibility highly. And so that means whenever we add something to C#, it's in addition to all the stuff that's already there, and it grows the language every time. And that should be cause for concern because eventually, the language might just be too bloated and too hard to wrap your head around, and you get a situation where people can't learn the whole language, or you will get different factions of C# developers working in different corners of the language. Like, in C++, you have the meta programmers and the, that's something that we worry about, and we try our best not to have the language go out of control, and for new features to fit in as smoothly as possible to the C# that's already there with a minimum syntactic footprint and so on. But we do it without being afraid of adding new things. Like, as long as it's something we believe will have value for a long time and is worth the extra complexity, we will go ahead and do it. We err on the side of moving the language forward. So again, if you have questions or comments on this, feel free to just jump in. We try to do things that benefit all C# developers. We started out being primarily an app programming language for Windows, but it fairly quickly and over time, more and more, it got to, or C# became much more, the usages of C# became much more diverse, and the domains that C# are being used in are staggeringly different, from still doing desktop apps to cloud stuff, to mobile, to games and Unity and so on. And so we want to make sure we're not out to favor one of these particular domains. Sometimes we add features that you might not have very many people use. Mostly that's around sort of low-level efficiency and safety measures that even if you don't use them directly, you'll benefit from somebody having used them further down the stack that you built on. So some low-level things will be mostly there to improve overall safety and performance for everyone. But they benefit you indirectly, even if you don't use them directly. And the third thing is sort of you can say the way that we steer C#. There's a I don't even say a balancing act or an interaction between, on the one hand, having, we've moved, this is probably where we've moved the most with the language, from being completely closed doors, like all the Microsoft technology 2 decades ago. All the decisions were made in secret, and everything was built, and then we came out at a conference shortly before shipping and said, ta-da, look what we came up with. And hopefully people liked it. And when it came, and for many technologies at Microsoft, they didn't. And we tend to try to forget as best we can about those. But for C#, remarkably, mostly people did like what we did. And I think that's primarily down to the amazing intuition of our lead designer back then, Anders Heilsberg, who just really he was a really good stand-in for the world's developers when it came to what would fly and what wouldn't. But it's not really sustainable to rely on one person's intuition, in particular, since he's not working on C# anymore. So the move to having more and more of an open process around evolution of C#, and now actually having for several years now, being specifically open source. We have all our artifacts that pertain to the language design just in the open, like all our source code. That has really helped, and having early previews, being able to have lots of conversations like this gives us a very fine-grained interaction with the community, and it helps us validate and improve our ideas before we commit to them and ship them. And that's a wonderful model. That really is what enables us to do the right things in C#. And at the same time, you have to be careful that you don't let yourself inundate with ideas, and that you sort of lose control of what the language is about. And so one of the things that we've held to ever since the start of C# is having a group of people that were strongly in charge of C#, and through all these changes have exercised stewardship over the language. And that's a C# language design team, which has been meeting constantly. We currently meet twice a week for 2 hours at a time to do the hard design work together as a creative process together, and with people who tend to be there for a long time and have a lot of experience, bring a lot of experience in. So that's how we get continuity and make sure that the language doesn't fall apart. If we can agree in that group, then we're not going to do anything rash, and the chances that we'll regret something later are much smaller. Not that it hasn't happened, but you can ask me about that later. So that's how we think about building C#. And if there are any questions or comments on that, now's a good time, because otherwise we're going to roll up our sleeves and get technical in a minute, as soon as I have a sip of coffee. Takes me into my developer aspect. All right, you are all being silent. And for that, I will reward you with code. Well, before we do, since this came up, since this was in front, this is our GitHub site for C#, the C# language. You can click in and find all the notes from all those meetings I talked about. Folder by year. The README has the upcoming meetings with agendas. Then notes get taken. We haven't taken notes for these yet, so they're still in here. Down here you have the ones that we did take notes for, little summaries of what we discussed, and then you can click through and see on September 14. Here's all the pros and cons and all the design rationale around these features. So we can go back later and see, why didn't we do that? Or why did we do it this way? And so the developers can go in and see what was decided and why. So very useful for us, but also a lot of people find it surprisingly interesting to snoop around in this and kind of find the heart of the discussion, and then you're welcome to. And of course, there's also discussions where people can throw loose ideas around. Once you have a strong idea, you make it an issue. If somebody on the LDM, the language design meeting, as we call it, the LDM group, if one of us finds an idea interesting, we will champion it. That brings it up for discussion in the design meeting, and then from there, it can either be thrown out or postponed, or we start working on it and hashing it out for real. So that's the process. And now to code. All right, so here we have, that's an update. We'll save that for later. Here we have some C# code. It's not particularly modern. one of the sort of recurring themes of C# is there's a long-term evolution in programming languages, I think, where we go from having things that are more terse and curly brace heavy and keyword heavy to modern languages that come out nowadays tend to be more sleek. There's sort of been an evolution in how much code is needed, and we try to gradually just sleekify C#, sort of do drive-by little language feature optimization. So you have to write less boilerplate, or you can have less indentation. You can write things with less indentation, and that every feature or every release has a feature or two that's all about. I haven't used this term before, but it just came to me, sleekifying C#. So it's just like you know, being middle-aged and buying a motorcycle or something. But so one of the things that we were like, this is actually dumb. This is a Javaism that we can do without here decades later, is that your main program, the thing that says what your program does, is buried in two levels of indentation and in meaningless declarations of types and methods that just have to follow a certain pattern just to make the compiler happy. The compiler, which is so smart, you have to tell it all this stuff so that it can find the main program. That's kind of silly. So we said, okay, that you don't have to do that. This is actually just obscuring the code. Let's just get rid of that. Let's let you put these statements at the top level of a file of your choice. And when we compile, we'll find that, call it the main program, and it works just like before, except you don't have to have all this goop around it. And so there's nothing new. There's no new expressiveness here. There's no like new capability in C#, but it does mean that if you come up to a small program, you don't have to dig in so deep. It means that if you're new to C#, you don't have to first, there's not as much stuff that you have to learn to ignore so you can write your first hello world, right? You just write it at the top level here now. So top level programs, a nice little sleekifying feature of C#9. Any comments or questions? You're so quiet.
How do you accept parameters?
What's that?
How do you pass arguments?
Ah, you mean like the args?
Arguments.
Command line arguments? That's we thought about that. We're like, you know what? Instead of doing something fancy, let's just put a magic variable in scope here. That's called args. Everybody calls it args anyway, because that's what the template puts in. So just so you can just access args. They're magically there. And other things that you can do in a main method, as of recently, you can make it async and await things in there. We'll do that implicitly for you. So if you want to await things, await task.run of some lambda that returns hunter, you know, be our guest, and we will just see that there are awaits in your main program, and we'll do the right thing and treat it as an async entry point. So we try to, as much as possible, not make this sort of like less expressive than the old way. There's a few places where it runs out of steam. If you want to place an attribute on the main method, we don't currently have a way for you to do that when there's no main method. And also the method isn't called main. So if you the one that's generated, so if you want to have a main method that you call from elsewhere, then yeah, declare it as a method. But other than that, it's expressiveness wise, it's fairly on par with the old way of doing things. Make sense?
Nice.
One thing to maybe also call out here is the method here. So this was a local function in which we've had for a couple of releases in C#, and it was inside of the main method as a nested local function there. And the way, so that was actually one of the big sticking points in the design here was people might conceive some other meaning when you have a method declaration at the top level of a file, of a source file. You might think that this is declaring a method for the whole, this might be an internal method that's sort of a top level function that everyone can call, and you can't. So this is still a local function to the main program. It is not automatically put into scope for the whole file. That's having like top level functions is another feature that we could do in C# one day, but we didn't. So instead we just blocked it off so that if somebody calls display name inside of a class or something, we just give an error. We bind to it, but then we give an error so we can make it work later. We don't like skip this one and look further out or something that might break. If we added the feature later, we make sure to reserve a right to do it properly later. And so then one day, maybe you can say public static and actually declare a function that is, when you do a using on this file, it's directly there, or you can dot into it directly from the namespace. But we haven't gone down that path yet. We just make sure it wasn't blocked off for later. Okay. You good? Then I'll change focus in this massive program here. There's a creation here of a person object. It's an object initializer, which has become fairly common. It's a good alternative to constructors. It has some different pros and cons, and some companies actually mandate that you should use this style because constructors can be fairly brittle. If you have constructors and you have an inheritance hierarchy, you have to make sure that all the right things get passed all the way up through the hierarchy, and if you change anything anywhere, everything else breaks, and so on. Writing a class for construction with object initializers is much simpler. You don't write any constructors, just use the default constructor, and then the object initializer just sets the value. So it's simpler in that sense. It also has some downsides. We can talk about some of those. But one of the downsides for object initializers is that it relies heavily on mutation. And so if I wanted to create an immutable object model, I can easily create an immutable object model. I can just remove the setter, and then these properties are immutable. That's easy enough. But now I can't use object initializers anymore because they rely on setting those things after the constructor has run. So there's sort of a fundamental clash here where you can't get both. And we want to make immutable object models more first class in C#. So we're a little sad that there's this exclusion between object initializers and immutability, and we wanted to do something about it. So the thing we can do about it is that we can make a version of the set accessor in properties that is called init. So these are called init only properties, and that means that they have a special setter, that special version of the setter that can only be invoked at the during an object initializer. So they can be used for initializing, but if we try to mutate it later, if we say person.lastname equals, let's say Scott Hanselman is trying to commandeer this object for his own purposes, then you get a red squiggle saying, hey, this can't be mutated anymore. It needs to be done in an object initializer. So, through this like little just variant of the set accessor, we've enabled the combination of immutability and the object initializer style. So I don't know if any of you are tinkering with immutable object models, but it has a fair amount of good use cases. One of the things that you do if you have if you have immutable object models, like we do in the C# compiler called Roslyn, for instance, Many UI frameworks do. Many times when you represent wire data, you would do the same thing. And then if you want to represent a change, instead of mutating the object itself, what you do is you create a new one that's like the old one, and except with one or two things changed. And that way you have both the before and after as separate objects at the same time, which can be very useful. Well, first of all, by not mutating anything, you can have a whole lot more concurrency without worrying about synchronization, because when you don't have mutable state, you don't have shared mutable state. So it's much more concurrency safe. But also it gives you the ability, this ability to represent state at different points in time, gives you the ability to roll back, for instance, or diff things. And whenever you see us use a refactoring in C# or in Visual Studio, we present the result of a refactoring. We show what will change. That's actually us building a new syntax tree from the old one with the refactoring applied, and then we diff them and show the diff, right? So it enables all these kinds of things. So it's very powerful and increasing use. So we want to enable that, but and that's what init-only properties do. But now you sort of get to the next level of, well, when you do that, the person sort of loses its objectness a little bit. Instead of being this encapsulated, evolving container of state with methods on the outside, then you have the objects represent values that are sort of snapshot of a given point in time. So you get a more value-oriented view of classes. And when you try or of objects, when you try to work with objects as values, as more just being containers of what happens to be inside them right now, then C# will sort of fight you on every level. We have reference equality, and this whole non-destructive mutation pattern of creating new ones from old ones isn't really supported in the language. Well, until now, because we decided that now it's time to start addressing that and to give you a version of classes that gives you value-ness by default, that makes them more like values and less like objects. And that's the record feature. So I'm changing my declaration here to be a record. It's still a class. It still creates reference types. They're still objects, but it's a class that has now been, the compiler adorns it with special abilities that affect the way that it can be used. So one of those abilities is the ability to do is support for non-destructive mutation. So I can say var other person. So instead of changing the person, I can create another person from the person with these changes. So you write an object and the new with keyword, and then you say some object initializer. And in there, you can initialize whatever members you want to change. And now you created another person object that's the same as the first, like a full copy, a shallow copy, but copying the whole object, even like if the variable was actually containing like a derived type, like student, it will copy that. The new object will also be a student. It will copy any hidden fields, and the object itself is able to copy itself completely. And then this object initializer is applied on top. So to illustrate that, we could go and display the other person as well. And let's try to hit the right buttons here and actually run it. So you can see I have both a Scott Hunter and a Scott Hanselman at the same time. The first name was carried over. So that way, we're sort of helping you with this non-destructive mutation pattern. Any thoughts or comments? I'm not going to be able to make this last 2 hours if you don't ask more things. You're gonna get so tired of my voice. I'm gonna move on a little with the records here. So the other thing records can do is that so the other value aspect of it, and this is one like value thing. The sort of corresponding thing when you view an object as just the sum of its contents and not having its own identity so much, where the object reference isn't really important anymore, then you also want equality to work that way. So records also automatically have value equality implemented for you. So if you go and say, let's create yet another person, the original person, where we change it back again, the person with the last name changed back to Hunter, then we should be able to go and see that while the person and the original person are different objects, they're the same value. And we can just right line interpolate a string here. We can say equals and call the object.equals method on the person and the original person. And that should, if I'm right, that should evaluate to true because the values inside are the same. Whereas if we went and we can do that too, if we went and do the reference equals, see if I can spell reference quickly here, reference equals, then that should show that they're different objects, but they have the same value, right? So if I go and say, run that stuff, you can see they're equals, even though they're different objects. So value equality has been implemented. And yes, we have our question. Somebody hopes, yes, Todd, I will be going over pattern matching enhancements after this. Yeah, once we're done with records, that's the next example. Press any key. There you go. All right, so that's sort of the main rub on records. Now there are some fancy things you can do in records, which I want to say that a lot of what we did with records and immutability in C#9, we consider it sort of the first step of a journey where we'll do more. And some of it we hoped to do in C#9 and we just pushed it out. But there are also some things that are still open questions and will be informed by the usage that these features get. We hope to have a C#10 already next year at the same time, and in general, to have major C# versions now go out every year, just like .NET is going to have a major version every year. We haven't like fully committed to it, but I think that's, I mean, I expect that to be our cadence going forward. So, some things, there's some things that we aren't doing yet, but there are also some things where we're starting to peel off and we'll generalize it later. So one of these is what we call primary constructors. So let me give you a primary constructor. Let's say that you do want to have a constructor on this person record, and that takes in a first name and a last name. Then you can put constructor parameters directly on the class instead of writing out a full constructor for it. So there's sort of an abbreviation of it where you just write the constructor parameters right here, and now they're automatically in scope. I can use them to initialize my properties and last name here, and I could also, let's say I wanted to have a base class. I could also let's say I derive from object is a stupid one, but I could also pass first name as an argument to my base class. It's like doing a base call from the constructor syntax itself. Of course, object doesn't take any constructor arguments, but you get the point. And so primary constructors are nice for that purpose, like just the abbreviation of having a constructor where you then can just use them to initialize from inside. And that's the main idea of primary constructors. And we want to allow those on all classes and structs, but right now we allow them only on records. And on records, they get a little extra bit of functionality. In records, we make, because we think that on records, it's very common that your constructor, I mean, you'll always want your constructor parameters essentially to be one-to-one with public data members, public immutable data members. And so we want to abbreviate that for you so that if you have a parameter that doesn't have a corresponding property declared in the record, then we will generate one for you. So there's still a first name property in this. You can see I'm not calling the right constructor, but I still have a first name property in this record because it's generated for me when I don't specify one myself. And as a matter of fact, it's generated to be exactly this. The ones we generate from primary constructor parameters and records are public init-only properties that initialize from those parameters. So it's exactly what I wrote there. So that means you can write if you want just that, you can write a really terse record declaration. And in fact, you don't even have to say the curlies. You can just say a semicolon instead if you want. So if you want constructors in your records, you can get pretty terse. You can still put other members inside of your records, including you can put other constructors. Let's say public person empty constructor, but it has to call. They all have to call through the primary constructor because it's putting things in scope in the class. So it needs to be called. So we could do something fairly ugly like this and call a primary constructor with empty arguments. And now, of course, there is an auxiliary constructor, and this works again. So you get the mechanics of it. If not, then shout. I don't know if I lost you all completely, or you're just like nodding along. Hopefully
So
not nodding on.
what's the case to use a record rather than a struct?
What's the case for using a record rather than a struct? That's a good question. And it's a sharp one too, because you're noticing that records are actually kind of like structs in a way. They have value equality like structs, and they can copy themselves. Like when you assign a struct, they also copy themselves. Like the with stuff here, that's really making a copy, a value-based copy. And so they are very much like structs, and we by default, we implement the equality and the with functionality to match that of structs, which means shallow copy, and we sort of do the equality and the copy the same way, so that they have familiar semantics from structs. When you the reason to use records anyway is the same reason to many of the same reasons to use classes instead of structs, which are you want to build a bigger data structure. Structs, by being value types, you can't have them nested within each other. Well, you can have one kind of struct nested within another, but you can't build a chain of the same type, for instance. You couldn't have person have children or something recursively referencing itself. And there's also just the passing by reference, which is more efficient. So depending on the semantics you want, typically, fairly advanced object model, not even very advanced, but even object models that, would come to you in JSON form over the wire and be deserialized, or that kind of thing, you typically need classes to represent them, because there's typically some, I won't say typically, that's not true. Often there's some recursiveness to the data shape that you're trying to represent. So you can also, an alternative view of this is they're sort of like advanced structs with reference that are reference types, but with value semantics still. Make sense?
Yeah, that makes sense.
Now, that brings up a question. Records can do extra things that structs can't do, like this primary constructor stuff. And shouldn't you be able to do the same kinds of things? Shouldn't you also be able to have the with support with structs and so on? So that's on the docket for C# 10 to think about. What about records and structs? So it may be that the record that we have in C# 9, we really retcon that as being a shorthand for record class. You can't say that today, but that's really what it means. And then you could also say record struct, and you would get the same benefits, but applied to structs. Or, an alternative design. So this is something we have to hash out. An alternative design is to say, well, all structs are records. We retcon all structs to be records in that we can just generate with expressions on top of the copy semantics that structs already have. Like, it would be the easiest in the world to just copy the struct value by an ordinary assignment already supported through all the versions of C#, and then apply the object initializer on top. So, and that's another design point, and we kind of have to, we still have some open questions about what's the right direction. Do you want to distinguish between record structs and ordinary structs, or should they all be the same? That's an open question. One thing people also sometimes ask is, you talk about values and immutability, but if we, let's go back to having some of the property members declared in here. There we go. What if you want to have mutable records? Can you do that? Can you declare this with an ordinary setter? And the answer is totally. Yes, you can. There's nothing that we do that prevents you from having mutable records. That's just fine with us. And that maybe we've gotten some feedback on that, but people are a little concerned about that, and I can see why. Because if you have value-based equality, you also have value-based hash codes. And if you can mutate those values, that means your hash code can change over the lifetime of the object, which is a big no-no if your objects are ever at risk of being put into hash tables or something like that. Things that you should use the hash code to find them. You put it into a hash table, the object changes later because someone has a reference to it and they mutate it, and now the object is sitting under the wrong hash in the hash table, and you can never find it again. So there are dragons when it comes to combining mutable reference types and value semantics and value equality in particular. But we still allow it. And I think one of the feedbacks we've gotten is, well, the feedback about this being a little dangerous is maybe, I'm going to go back to the team and say, hey, why don't we put an analyzer in Visual Studio that you can use to tell you if you don't, that you can turn on if you don't want to write mutable records. But I think some people do want to write mutable records. You might very well want the with semantics even with mutable objects. You might want to have mutable things in there. And if we get to records, just like for caching purposes or whatever, and when we get to record structs, I think there's no problem there with mutation. So it would be odd if class records couldn't be mutable, but struct records could, and so on. So we're leaving it open. We've decided to leave it open for mutation, but maybe we should do something to allow people to get a warning about it if they do this. I can imagine many people will be like, I want you to stop me if you do this. And I get that point. All right. So, want to talk about patterns? there any more questions about the records, the init only stuff? Now's a good time. You can come back to it later, but all right. Moving on. Here's some patterns. This one also wants to update. So pattern matching is a feature area that's been gradually evolving for a couple of releases of C# now. And whoa, there's a Z there. Why is there a Z? Huh, that's interesting. C#9 is no exception. There are also a couple of things in patterns that we do, and some of them are pretty nifty. So this is all C#8 stuff. You might not be fully up to snuff on what's going on with patterns. So I'll give you like a quick tour here. This is a helper method that is sort of like very modern C#. It's got an expression body. So there's just one big expression as the body of this method. And that one big expression is a big switch expression that switches on the vehicle and applies patterns to it all the way through the switch. And the different cases of the switch will then produce, let's look at this one, for instance, it'll produce a result that becomes a result of the full switch expression and therefore of the whole method, right? So that's all very expression-oriented programming here. And, you know, this one's fancy because it's got another switch as the nested switch on one of the members of the car that it established in the outer switch that we were looking at. So there are still some things that can be improved here. One of the things that we said was in C#9 was it's kind of here you have you're saying any other taxi. I don't care I don't care about the specifics of the taxi. In fact, I don't care about the taxi at all. We make you put a discard, we might as well not make you put a discard. So that's a tiny little improvement that pure type patterns don't need the discard. They can just be written like this. It's similar to how in an is expression, that's how is expressions always worked. You could always say is taxi. And it was only later that we allowed you to put patterns and say is taxi T, so that T can get bound to the taxi that it is. So just sort of ironing stuff out there a little bit. Now there are also, and we could do that here in the delivery truck and so on. But another thing that that you see in these examples is that we have these comparisons to constants. So we have these relational expressions that compare to constants. And we decided, hey, let's also make those patterns. So we could actually, if we look at the delivery truck here, instead of having this when clause that applies an arbitrary Boolean expression to the delivery truck, we can write this differently as a nested switch on the T gross weight class value here. So we could say if it's a delivery truck T, then switch on the gross weight class like this. Switch, there you go. And as you can see, we don't get red squiggles until we get further down. This here is an absolutely valid pattern in C#. It's a pattern that means values that are bigger, ints that are bigger than 5,000. That's what this pattern means. So we can go in and do the same down here. And this last one here, we can just make a discard for now. That's all the rest of the gross weight classes. Let's round it out like that and do some indentation. And now we've rewritten this delivery truck handling as a nested switch that applies these new relational patterns. So that's fairly nice. But these patterns are they're sort of oddly out of order, right? I would want this is the one. This is the I would sort of put them in order. This comes first, then this is in the middle, and then this comes last. But if I only have these single relational patterns, I couldn't write the thing that would put this in the middle. But I should be able to. And in general, it's fairly often that you want to combine more than one pattern. And so we said, what the heck, let's add let's start adding a language for combining patterns. So now we have and, or, and not patterns that apply to other patterns. In particular, we can apply them to the relational patterns here. So we could say greater than or equal to 3,000, and it should also be less than or equal than 5,000. Okay. So this is an and pattern. I happen to apply it to relational patterns here, but we can use these pretty much anywhere. Right? Another example would be that I could apply the not null pattern here. So that's a not applied to a constant pattern of the value null. Okay, so some of you might have a question around this, and I'm going to anticipate it since you're not asking it, which is, why use keywords here? Isn't that kind of VB? And I know that you're the C# and VB user group, so some of you will cheer and some of you will cry, but small break for coffee. The fact of the matter is we couldn't use the usual C# double ampersand or something like that here, because patterns are full of expressions that these might apply to, and not only that, but expressions are full of patterns. The is expression can have any pattern, and so being able to disambiguate and avoid parentheses, like parentheses hell around when is the double ampersand applying to the patterns and when is it applying to the expressions inside or outside the pattern, we just said that's just going to be terrible, very hard to work around and very hard to reason about when you see it, and very annoying with parentheses everywhere. So we said, okay, for this, we're either never going to do it, or we're going to accept that we're going to use a different syntax for the and, the or, and the null. And then we just took the keywords for that. So that's sort of a cop-out here, but actually also, it looks kind of nice. It's clearly something different is going on than normal logic. Clearly you are, and so it kind of nicely designates that there's a different kind of combination going on. So as you can hear, I've learned to rationalize it to myself and hopefully also to others. So now that we have that, we can take this line and move it to the end, because none of them is a catch-all anymore. Well, whoa, what happened there? Oh, comma. There you go. Another thing that's generally been true about patterns, and that's still true, is that these patterns are constant, and we try to do a lot of analysis around them to make sure that you're using them correctly. So let's say that we just put 4,000 here instead. Now you get a warning saying that you're not actually, this switch is not covering all the possible values. And it's even it's very cute, it's giving you an example of a value that is not, that's not covered by the pattern. So 4001 would fall in the range between 4,000 and 5,000, which, yes, sure enough, we're not actually dealing with anymore. So it's telling you that nicely. There's also checking that all the cases are reachable. So if I put a useless, like if I made one of these patterns so that it would cover everything after it, if I say less than 13,000 here, then this second one here is completely subsumed by the first one. Like everything that would fall in this range also is less than 13,000, and I'm getting an error saying you will never get here. The previous pattern is taking care of all of it for you. And so we try very hard to help you, because patterns can get kind of complex and you have a lot of them. We try to help you make sure that that all of your patterns make sense, that they are not subsumed by previous patterns, and that all values are handled. That's great big analysis that goes into that. As soon as you start using when clauses, that kind of goes out the window because we can't analyze the arbitrary Boolean logic that's in here. So that's one reason why whenever you can do what I did with the delivery truck here and break it down into sort of pure pattern usage, you get better coverage of this analysis. You have higher confidence that you covered everything. All right. Not seeing questions on that. Anyone wants to shout one out? That's all right. I want to show you something cool. So down here, here's another method. It's another helper method. It takes a date time and gets the hour out, and then it does a big if-else on what the hour is and gives you back an enum value of the enum time band, depending on when during the day it is. If I click here, I get a little light bulb, and it's giving me some new refactoring options. For instance, I could convert it to a switch expression, and now this refactoring takes all that if-else stuff and it turns it into a switch that applies these new relational patterns to give you those time bands. You see that it gives us a fallback of overnight for things that are after, so after 20, as well as the first one is like before 6. We could combine those with an OR pattern. Actually, I haven't done that before. I've speculated about it. Or greater than or equal to 20, I guess. Apply those two patterns, and now we capture everything overnight in this first one. And now you see that it's very hard to see, but there's a red squiggle on the last case here, because now all the cases are covered by the switch above. If we comment this one out, everyone's happy. So there you go. Was that what you were hoping to see with patterns, Todd? I don't hear anyone talking. I hope it's not me who's lost audio. If oh, he's saying yes. Anything more? You could get rid of the temp variable hour. Absolutely, you could. Though that's like old hat stuff, right? But you could definitely now start to let's see. Is it here? There's a refactoring. I can never remember if it's on the usage or on the variable. There's a refactoring. There it is. Inline temporary variable, doing, and now you can turn this whole into an expression body. And you know, it gets worse and worse. Now it's just as bad as the one up, you know, further up there. Yeah, Sam says you should not feel shy to unmuting and put questions in words. But on the other hand, you know, some of you might have food in your mouth or something. It's fine to ask them in chat as well. So yeah, so more things. One of the actually let's we have plenty of time here, so let's dawdle here a little more. So one of the things, this is cool as far as it goes, right? And it makes things more and more expression oriented. But sometimes you're in the middle of you've moved over to switch expressions inside of expression bodied methods, and the switch expressions have expressions as their branches, and everything's good as long as you can stay within expressions. But if you wanted to do something deeply inside of this expression structure, where you actually wanted to do an extra statement, let's say you wanted to do like a little debug write line, or you want to sneak something in like that, or a little assert something, then how do I sneak a statement in there? We don't have a good answer for that. We have some half good answers. Let's say I wanted to, on this particular one, I don't expect this to be the case, but I want to assert something, or debug.assert, or if I had included that, or some wanted to do something in there that is before the expression gets executed. So some sort of like statements, some form of statements inside of expressions. That's something that we've been debating a lot, and we haven't really landed on. Is this even okay? It seems that the more expression oriented we get, the more necessary or desirable it becomes to be able to like poke a little hole and stick a statement in there. The best options you have today, is to have a local, declare a local function somewhere. But where do I declare that local function? Because that's declared at the statement level. There is no statement level in this whole method, right? Or you could like turn everything into statements. So it's a real problem that we sort of created for ourselves by making everything so expression oriented. And I think we're sniffing at this kind of approach to just hack these in. But I'm always curious to hear if you have opinions on that, or because it feels a little dirty to be sticking statements inside of expressions, and it kind of looks a little bulky. But yeah, it's tough not to have. So that's one of those things that's on the radar for us, but unresolved as of yet. Happy to hear any thoughts on it. I'm going to get it back to compiling here. There we go. Oop, I went too far. I ruined something down here. It doesn't matter. Doesn't matter. Oh, that was that one there. Yeah. Yeah. So as for me, I'm done with patterns. That's all I had to show this time around. There's a few more C#9 features. There's actually a lot, but I have a few of them in slides. We can go back and look at slides now. Just want to make sure we're okay to move away from the code. Otherwise, you can always come back to it. So here we are, other C#9 features. Target type new is one of them. Sometimes it's just annoying to have to say the type of the object when you create it, and you're like, really? Is that annoying? But sometimes, yeah, it is really annoying. Now, this particular example here, I could just say var, and then I would only have to say the type once. But in cases where you already have the variable, you're passing to a method or something, then you can really save a little by not having to say the type, especially if it's a big like generic type or long name or something like that. But I also think of very repetitive scenarios, like I'm creating an array of things, and I know what the element type of the array is, and I'm newing up all these things inside of the array initializer. But do I really have to say the type of each and every one of them on every line of code? Not any longer. With this target type new, if there is a type that the value is clearly going to, if there is a target type, then we will be happy to substitute that in instead of, and you can just leave the type out of the new expression. There are some things that are a little complex, like what do we do if we're passing it to an overloaded method and there are multiple different things that it could be? And the answer is that we try to not be too smart about it. We will be fairly quick to give you an error saying we can't figure it out. And that's not to be dumb. That is to protect you from the inference that goes on at that spot being too brittle. Like if you do little adjustments on your overloads or whatnot, it shouldn't be able to too easily break your code or make it mean something else. So we want it to be fairly clear which one you meant. So that's a little feature. Another one that you might find occasionally useful is covariant returns. So this is the idea that when you have a virtual method you can, as you override it down the hierarchy, you can tighten the return type and provide more and more specific types down the inheritance hierarchy. And the benefit of that is, well, first, you know, it will keep you disciplined about what you put in the body. If you actually want to make sure it returns a student, then the body will be checked against that type. So that's good for your own sort of discipline as you write the methods, but also as you call them. If you knew you were inside of that class that had that override, if you knew that you're being called on that, then that stronger type now becomes available, and the consumer doesn't have to cast to student when everybody knows that it's a student. That's now given by the signature. This is one of those things that this gives me an opportunity to talk about something that has changed over the years in the relationship between the C# compiler and the .NET runtime, or the CLR, the virtual machine that executes the code. So in order to do, so there are kind of two ways to do a feature like this. We could either do it with compiler tricks, which would create a hidden extra method and have kind of like chain them together. So there'll be a secret stub method underneath, and that's how Java does it. They've had this feature for like 15 years or so, and they do it with that. But that's a brittle approach, because if things aren't compiled in the right order, then they won't match up, and you end up with unexpected problems where the seams show of how you implemented the feature with compiler tricks. So we waited with this feature until we felt we could actually implement it in the runtime itself, so that it's done properly and so that it's robust across these kinds of changes. And that is, in general, touching the runtime is something that we were very wary of for about a decade or so. After we added generics in the early days of C# and .NET, we're like, oh my God, a lot of people have .NET as a Windows component, and we can't actually know which version they have, and we can't be sure that they have a new enough version that language features that depend on new features in the runtime can actually run on end user machines. So this whole, like the whole deployment story around .NET back then meant that it would be really sketchy to start implementing language features in the runtime directly and relying on those things being there. And we just didn't. We stayed away from that. And many features, I think, that we did in that period of time, in hindsight, would have been better done with more participation of the runtime, but we just didn't dare to do it. I'm thinking here of things like the closure, the capture of locals around a lambda, or the state machine that we use in async. All of that is very advanced compiler magic that is fairly brittle, and it also compiles away a lot of useful information that if the runtime had it, it could do a much better job at optimizing. There are things in async state machines where we know this will only be executed once, or we know a lot of things in the compiler, and that knowledge gets thrown away and becomes lost for optimizations at runtime. So now that we're all in the .NET Core, now that all of .NET is .NET Core, essentially, the next version is simply called .NET 5. New C# versions are only supported on the latest .NET, on .NET Core descendants, where the distribution model is different. And now we're getting back into the business of doing language innovation in the runtime, of implementing things where they belong. And that feels really good. I know that there are some downsides to new C# versions not being supported on old runtimes or on the classic .NET runtime, but there are upsides too. And one big upside is that we can evolve C# across the whole stack. We can do things where they belong because we have a deployment model for the runtimes that's robust. So we're taking advantage of that. C# 8 added default implementations and interfaces in the runtime. C# 9 is adding covariant returns, and we keep on adding things to the runtime and taking a dependence on them in the corresponding versions of C#. So that's a great new opening for us. I've got a little story in about that. Any questions on some of this? I'm about to get unmoored and move into the more distant future. So we're done with what's happening in C# in a couple of months, and now we'll move to what will happen over the next couple of years, or what might happen, because nothing is set in stone yet. So here are some of the themes I talked about, that sort of general themes. We'll just keep doing more of that. This whole complex around records, around initialization, and around immutability, you already heard me say several times as I was showing that this is something that we'll keep working on. And I mentioned some of the things we'll do, or that we plan to do. Beyond that, there are many other things we're looking at, some of which are a little bit speculative, but also kind of cool. So I will, time permitting, we'll get into some of these over the next half hour or so. So first, let's dive into some of the things that we envision or will try to do in C#10 around the records and immutability and initialization kind of complex. And if there's something that you expect and don't see, shout it out. Why don't you do this, or why don't you do that? I really want to know. I'm here to hear your reactions, and that helps me do the right thing. And unlike C#9, which is locked and loaded by now, we would have to throw a fairly big exception to change anything at this point. C#10 is wide open. So you're thinking something, say it. Anything's possible right now, and your input is useful. So one thing we saw was that if you use that primary constructor syntax on records that we did at the end, you could get a very terse record declaration. And that's great, but it's also, in a sense, not so great, because it puts the object initializer way of doing things at a relative disadvantage. Right now, we have this very terse syntax for when you want to have a constructor, but not so terse when you want to do it the object initializer way. And it would be nice if that was short too, so that so that you could have these really tiny, tight declarations for just plain old data that without going into the constructor mode. And that's what we're thinking with data properties. So this very same syntax that was abbreviated in the primary constructor example before, we would also allow that to be explicitly abbreviated as a member declaration. So we're thinking to call them data properties, and they're simply identified with the data keyword and then followed by what looks like just a field declaration, but it really is a public init only property. So so all that code there gets abbreviated to this, so that you can have some. They become short enough that you can write types as one-liners and have that same terseness, or almost the same terseness around them. So so I think that's, as it's, hopefully it'll become fairly common to have init only members. We think that this will be a big help. It's often when you have this value, but I'm doing it here just in classes, but you would also do it in records. When you have this sort of value-based approach and the immutability, they often come together with, and they are often the situations where, because your objects aren't mutable, you won't have a whole lot of, and aren't encapsulated, you won't have a whole lot of methods on them and so on. You really just want plain old data, and any functionality is on the outside. That'll be with switches or elsewhere. And in those cases, it's good to be terse, and it's good to be able to just look at half a page of code and all your data definitions are there, or a page of code, and all your data shapes are defined there. That kind of terseness, we know from other languages like functional programming languages that's just very nice. So we have envy of that, and we want to get there ourselves, but without sacrificing the non-constructor approach to it, and while still supporting inheritance very deeply. All right. Next thing here on the list is that, it's fairly common to have various patterns around factory methods. Essentially, any reason you might have to not let people directly create the object, but give them a helper method to do it. It might be that you want to decide which object, which exact class the object is of. It might be of a derived class, depending on the input, or it might just be helpful. Oftentimes you have factory methods that are just static factories, and all they do is to essentially give you generic type argument inference by being methods instead of being constructors and stuff like that. So there are all these reasons to have static factories or virtual factories and whatnot. And that's all great. You can just do that. No need for a language feature for that. But if we did have some feature in the language, I put it here as a attribute, but it could be an actual keyword. We might make it an actual keyword. If there was a way that you could designate a method as a factory, then we could get some extra bennies out of that. And so let's say that calling it a factory explicitly puts some new restrictions on the implementation. So it would be forced then to actually return a fresh object. It would have to call new, either directly or indirectly by calling another factory. But the object returned would have to be a new one. So people who call a thing annotated as a factory, they have a guarantee that they're getting a new object. Now we can, because of that, we could now allow object initializers to be applied to such a method call, right? So because this is returning me a guaranteed fresh object, it is fine for me to apply the object initializer and even initialize this init only property. That's the last name. By calling things out of factory methods gives you this ability to apply object initializers in more places. Because again, factory methods today suffer from the same thing as constructors suffer from, that you kind of have to give everything. There has to be one with exactly the right signature for you to give the data that you care about. That often leads to needing more overloads or needing to pass dummy arguments or whatnot. This would shortcut some of that. So we're interested in allowing factory methods as first class. That again pertains to the initialization theme. Now, one interesting thing is that if we do that, then one of the things I guess I didn't say so much about records is that records are mostly just compiled down to a class with a bunch of extra stuff in it. And they are really like class declarations, but they do have a little bit of magic in them. And that magic pertains to how the with expression on records is supported. And the way it is actually supported under the hood is there's a special magic method that the compiler generates and knows about that supports copying the person virtually, right? So it's overridden in every record declaration, overwrites it so that it will always copy the most derived type that it actually has at runtime. And then we return that to the user and allow them to apply an object initializer on top of that in the with expression. And so we do our own housekeeping to make sure that because these have a special magic name, we can maintain in the compiler the guarantee that they always return a new object. But if we make that a language feature, then that would sort of remove the last bit of magic from records, and they really just become syntactic sugar for something you could have written yourself, which is a nice property to have. Like you could really have a refactoring that takes a record and turns it into a class declaration by putting extra declarations, member declarations inside. And this is sort of the, if we did factories, this would be the last step for that. Dave says, would this enable deep copying of a record where one of the properties of the record is an object? So yes, this would allow you to write your own logic in a record that that goes deeper than the default. But that said, you can actually do this. You can actually do that already today in C# 9. That's a way of doing it. Since we have a good amount of time, I can go back and show you a little bit of, kind of outline what that looks like. So if we go back to the record declaration here, what actually happens, the way that with is supported is, yes, it has that magic virtual method, but the virtual method doesn't do the hard work itself of copying the person object. It leaves that to a constructor that the compiler also generates, that is a protected copy constructor. So records have an extra constructor in them that takes a person, that is the original, and returns a copy of it. And this is where the logic is that does the first name equals original.firstname and so on, that does the actual copying. However, notice that I'm not getting any squiggles for declaring this member myself. So in general, in records, it generates a lot of things for you, but if you write them yourself, it will just use the one that you provide. So even though you can't touch the magic virtual method, the magic virtual method will call your copy constructor instead of a generated one when you provide one. And so in here, you can provide logic to drill in more deeply. If you wanted to copy first name more deeply, or you had some nested object that you also wanted a copy of instead of the shallow copy of just a reference to the original, this is where you can do that. So there's a backdoor already today. And all the magic virtual method does is to string those, well, they're actually even strung together by, if you have let's say you have a student derived type here, its copy constructor would call the base copy constructor and so on. So it's all like neatly zipped together, and you can insert yourself in all of that if you want to. And all the virtual method does is call the most specific one so that the right type of object gets created. Then it copies itself all the way up, then it gets returned, then any object initializer in the with expression gets applied on top of that. So even now you can do this. Now if we did the other thing, if we go back to the slides, if we did factory methods, then we could choose to give them, and we probably would choose to give the virtual copy method, clone method, I think we call it. We might give it like an ordinary name rather than a compiler mangled name. And in that case, you could even interfere with that and be more smart about even what type gets created, or choose an alternative to calling the copy constructor or something. So that would give you even more power. But I think the main thing that would give you is, today we don't let you mix in an inheritance hierarchy. We don't let you mix classes and records and other classes. You can't have a class inherit from a record or a record inherit from a class other than object. They are sort of separate. You have to be in a hierarchy of either one or the other, because otherwise too many things ran away from us. And this with mechanics is one of those. But this might allow you to interject class declarations in between record declarations if for some reason you didn't want to overwrite the equals from the base class or something like that. Those are kind of like advanced scenarios, but you can totally do them. So yeah, that was a nice little detour. Thanks for that. Another one of the drawbacks of object initializers that we're eager to address is with object initializers, they all get, like the one up here, they all get executed after, after the constructor has run. And that means there's no place to do like final validation of the state of the object. What you want is to be able to validate the object or do anything you want to it to kind of finish it up. You want to be able to do that after the object initializer has run. So at the end curly here, really. And we're thinking about adding another kind of member to declarations, not just record declarations, but class declarations, that we call a final initializer. So it might look like this, where you declare simply a body of code with the init keyword in front. That is the stuff that happens at the end, after the constructor is done and all the object initializer stuff is done, whatever logic is in any factories that the object initializer gets applied to, and after everything is done, the init gets applied on the created object and up through the initters up through its chain of inheritance to do final validation and whatever final nip and tuck that you want to do on the object state. So that gives you that place that constructors have traditionally been to do the whole object kind of validation and cleanup. And again, this is not just for records or for immutable scenarios. I think this is something that many people with deeply mutable data models today would also benefit from. If you in any way rely on object initializers for your creation, lots of people have patterns that are, again, conventions where they have a validate method or something that they call on the finished object after, and they have to remember to do that. Maybe they have to build their own Roslyn analyzer to remind them to do that and all that kind of stuff. Be nicer if that was just built into the language, and that's really what this sort of is. This is sort of like the validate method pattern built into the language and automated and guaranteed. All right. Onwards and upwards, we have, we talked about the primary constructors. So we would allow primary constructors on any kind of type. Again, just ordinary classes or structs, just fine. The only difference would be we would not put public members in your type automatically, because that's sort of like a records only kind of special case where that is likely to be desirable. So they will be in scope still for the whole of the class body, and you will be able to use them to initialize. You'll also be able to use them from within any, I don't have an example of that here, but from in any method body or so on. And if you use them in a member that needs access to them after the object initialization is over, then yeah, we need to store them inside of the object, and we will just create a little a little private field to hold them in so that the method can get at that later. So there'll be some capture, and we think we're fine with that. If people are worried about capturing these values, analyzers, yeah. So we think that's a good thing. And of course, again, here, primary constructors would be able to call up through the inheritance chain just by applying constructor arguments to the base class. All right. For this feature, there's a question about, well, what if you want to provide a constructor body for the primary constructor? Where would you put that code? And we think that we could come up with a syntax for that. We don't know whether we're gonna add it right away, or we're going to see if it's necessary or whatnot. But we think that it's fairly easy to come up with a syntax for putting just a constructor body in there that is sort of like, that belongs to the primary constructor. Of course, the flippant answer is just go and write the proper full constructor if you want that. But we might be a little more helpful than that. Maybe it's just person open curly, and that kind of looks like a constructor. Or maybe using the final initializer is how you do that. If the objective of that constructor body is to validate your input, not your final state, then you might want to have a constructor body for that before you say, oh, the object is fine, go ahead and initialize it and then throw on initial input. So we might want to provide some syntax for providing a body here.
I was wondering, is there a way that, similar to like how TypeScript works, where you could change the level of access for the properties in the constructor?
Yeah, so TypeScript allows that particular thing to be added to they have some, not exactly primary constructors, but a somewhat similar thing where you could put an access modifier on there, and then that would apply to the field that gets generated. And we could imagine in C# we could imagine going even further, like letting you both put like public or protected here, but also allowing you to declare it as a, do a full property declaration here instead. But whenever we play with it, it just feels ugly. And we just like, why don't we try to hold the line on these parameters just looking like parameters and not adding anything unparameter-like to them for now. So if you want a property, you have to declare yourself a property, like I'm doing here with the data property in this case. And then keeping these just parameters, the other stuff felt like all of a sudden you're writing things that shouldn't be in parens on a single line. Now you're just shoving things into that syntactic form that belong between curlies with semicolons and stuff. Now, that may just be us that are too conservative, but it just poked us in the eye too much. And we're like, let's hold off on that. If we're wrong, we can add it later. But if we're right, we'll be happy we didn't do it. So we're not going to even allow the access modifiers here. If you want something public, you declare it and you can initialize it from that parameter, like I'm doing here, or you can make it a computed property that just returns the value of that parameter every time, and then it will get captured into the object and returned every time. So, but yeah, outside of records, public members still need to be specified. They still need to be declared. Yeah. I don't know what you think about that, whether that's going to annoy you. I'm happy for your input on it, but that's where we are so far. Sometimes when we're in doubt, we do the most conservative thing, and then we'll see if there's like a groundswell of an uproar that we didn't go far enough, and if that's the case, we can go further. But if we go too far, then there's no putting the toothpaste back in the tube, right? So this is an example of that. And now that we ship major releases every year, if we're wrong, it might not even be that long before we fix it. Good?
Yeah, that sounds good. Yeah, I was just wondering because I've been using TypeScript lately, and
right. No, and it is kind of nifty. But on the other hand, on TypeScript, you have to do the constructor declaration in the body, right? You don't get to have this primary constructor thing, if I recall correctly.
Yeah.
Actually, all the way back when we designed TypeScript, because Anders and I were on the team that was designing TypeScript in secret way back when, and we started out having this syntax. This very, apart from, just with the types after the names, because that's how it is in TypeScript. And then JavaScript came out with their classes proposal after we had sort of almost committed to this, and we changed it last minute to match the JavaScript class syntax, which does not have parameters directly on the class. But this was almost the approach that this primary constructor business was almost the approach that TypeScript came out with way back then. So a little insider thing for you there. So speaking of validation, so with nullable reference types, we made it so that your caller, if you declare your parameters as non-nullable by not putting a question mark on the type, your caller will get a warning if they try to pass you null, but only if they have nullability turned on, and only if they respect it, and only if they're a late enough version of the compiler that it even understands it, and so on. So there's always this risk when you have public surface area that even though you say you will only deal with null, or you will only deal with non-null values, they'll give you null anyway. And so we often recommend, like if you're in that situation, you should probably check for null, unless you're fairly certain that what the body of your code does with the value is robust against it being null, which it really isn't here, right? Because that might just seep in, and the null might become the value of this property without you knowing about it. So it's always good to check. However, writing that constructor body or method body, or depending on what these parameters are for, and starting out with if blah de blah is null, throw new argument null exception blah blah, next one, you end up with a couple of lines of this stuff just even before your typically trivial logic kicks in, right? That's just annoying. And I think, by far, argument null exception is the most explicitly thrown exception by far in code, right? Followed by a distant second is probably argument exception. So argument validation is what people use exceptions for above and beyond anything else when they throw them themselves. And what if we could just do it for you? So that's what this is for. So, and this almost made it into C#9. There was an intern made a beautiful prototype of it and everything, but we didn't quite make it in. So we're keeping this for C#10. But the idea is you just put these bangs on your 2 exclamation marks on the parameter, and what that means is, and I really, really mean not null, and so I want it to be checked, right? So this will generate that check, and will throw the argument null exception for you. So again, it's just removal of boilerplate, but really like a very common situation, and even more common maybe now, or more annoying now that we have otherwise removed so much knowledge from with null NULL-H from source code with the nullable reference types feature. So this kind of rounds out that feature very well. For the longest time, we thought it should be just one bang, but then we also have the null kind of forgiving operator, the warning suppression operator that's a single bang in expressions, and we didn't want it to, in one place, be more lenient, and in another case, be less lenient. So we set double bang. That's sort of the damn it operator that really, draws a line in the sand here. So I don't know if that seems useful. Do you have many argument null exceptions in your code? I know a lot of code that does. I mentioned struct records. I think I probably said everything there was to say about that previously. And that gets me to the end of what's almost certainly on the C#10 dock it, and we get into slightly more esoteric stuff. Though I'm really going to try to push this one. I'm really going to try to push for C# 10, but I don't think it'll make it. I think it's too, because this is something that requires runtime changes and so on. I think we're just it will take longer to get it right. But it's a really good feature that has been prototyped a couple of times, both a decade ago and again recently in the mono runtime. And the feature is allow interfaces to define static members. And I think the most compelling, there are several scenarios for that. The most compelling scenario is abstraction for numerics. So one thing that C# really sucks at is numerics. It's just not very good for writing math. At least it's better than Java because it has operator overloading, but that's not saying much. If you want to start abstracting over your math code in particular, there are some other issues like we don't have good enough math libraries and so on that we could work on. But like a cornerstone of that would be, I can't even write a generic algorithm that's numeric. I mean, I just can't. There's no way to abstract over what operators you have and so on. And if you could have interfaces specify static members that classes or structs that implement them have to provide, then that would include operators. And now we can sort of go to town, right? Now we could say, hey, here's an interface that represents things that have an operator plus and a way to get a neutral element for that operator. That we will call 0. And any type that implements that interface will have those two static members. That's guaranteed. So for instance, a candidate amongst our core types is int, right? Int would have these, would easily be able to provide these operators. It already has a plus, and we could give it a 0 either as a new public static member, or we could maybe it explicitly implements that static member from the interface. And I might not have to write the plus implementation, because even though the plus for int is actually like language provided, it's not part of the int32 type, but the language would be smart enough to recognize that and put and make sure that the plus operator from the interface gets properly implemented. So now we have an abstraction over numerics, and we have a way of applying it. Now we could start using it. And so I could write a simple generic numeric algorithm. And you can, of course, imagine this becoming much more fancy with less. This is sort of like a toy example with a very simple interface and a very simple generic algorithm. But hey, I'm taking an array of things, of t's, where t is the type parameter, and I want to summarize all the t's. I want to add them up with whatever addition that those t's have. So I'm constraining them to implement this interface, and now I can have an accumulator that starts out by being the 0 of this t, the neutral element, and now I can apply the plus. I can even do the compound plus equals here, and that the compiler will, or rather the runtime will know to expand that to call the plus that the particular t that's a type argument uses to implement the plus operator in the interface. So it all kind of hangs together just like all other generics that's constrained today, but with static members, with the t dot 0 static property and with the plus operator here. So it's actually very simple. There's not much to it. And then of course we could take an array of ints and pass it to the add-all method. We will infer t to be int, and that satisfies the constraint. And the JIT will specialize, because int is a struct type. The JIT will specialize the generic method and fill in int everywhere and JIT it to very efficient numeric code. So you could do this. This abstraction is not only like general, it's also like generics in general and generics on value types in particular, it's also very efficient at runtime, right? Because it specializes to the specific types. That's how it implements. That's how the JIT deals with value type arguments. So this feels like it would be a great foundation for a math library. And indeed, when the Mono folks, Miguel and others, went and prototyped this recently, they also prototyped a library of math interfaces just to also have the proof of concept that you can actually, that this is not just like in principle this could solve numerics, but that there's actually a sensible library of numeric types that you can have that we could put in the core library and offer that would let you abstract over all our built-in numeric types, all the ones that you want to create yourself, if you want to apply these interfaces to your own matrix implementations, or and so on and so forth, right? If you ever, and you know, if we ever wanted to get better at things like machine learning in C# and so on, we need a strong math foundation, and this would be, I think this would be a key element in it. So I'm pretty excited about this. Any questions or comments on that? Is this confusing or clear enough, or do you like this, don't care?
I think it'd be a good addition.
Cool. That's one input.
Yeah, I think it's really good. Steal some of that Python code back into C#. So.
Right. I mean, we've done some things to make numerics better. We have the index and range support now in C# as of C#8. That gets at some of the other functionality that makes Python nice for big data. But I think this is the kind of thing that Python doesn't need this because it's essentially untyped. But to have not just to make numerics code strongly typed, but also to use the types to make it efficient, you need something like that. So yeah, cool. We're coming up on the end. Do you guys have more thoughts, other things about C# or whatnot? I mean, I have one more thing I can show you, so kind of quickly, I mean, we can do that for the next 5 minutes until Sam wraps it up, or we can talk about what's on your mind. Discriminated unions. Okay, so this is, I don't know if everybody knows what discriminated unions are, but it's the idea that it's one way of putting it is that discriminated unions is how functional languages do inheritance, but that's not really right because it feels kind of different. It's a discriminated union is a type where it has one of a fixed set of shapes, and then you can ask which shape it has and get the data that's in that particular shape. So you can kind of pattern match your stuff out of one of these, this fixed set of options. So it is a little like inheritance, like sort of one level inheritance, in that you have concrete versions of something that's abstract and doesn't have a shape in and of itself, but it feels kind of different. And it also has different properties because there's there's a limit. Unlike, you can always inherit from a class and have more and more different derived classes, but with a discriminated union, you can in most of the languages that have them, you can more or less, you can specify the specific list that are the only possible options for this type, and that leads to several opportunities in the language. First of all, it means that it just means you're protected from anyone hacking into your type and putting, kind of getting into your what was supposed to be a closed system. But it also means that if you're doing a switch on this type somewhere else, you know that there are only these 7 options, and therefore you can sort of do completeness of this at the point of switch. You don't need to require a catch-all case for what if there was an 8th one that came along? That's just not an option. Another thing that would enable potentially was that you could do discriminated unions that are stored in structs rather than in classes, because we could sort of like do like almost like unions in C, but type safe, where whichever one is the biggest, we make the struct that big, but and that plus a discriminator that tells you which one it is, and then we could actually make discriminated unions value types, even though they can have multiple different shapes. We would just overlay the different shapes in the same space in the struct, because they would only have one of them at any given time. So a couple of nice things that you can do with discriminated unions, but there are also some core design questions about what should the syntax be? Should this be more like, just like, Scala has something called case classes, which is essentially, it's still just inheritance. It's written the same way, a base class and some derived classes, but with the limitation that you can't derive from the base class outside of this file or outside of this compilation. So that's sort of the closest to object-oriented programming that you can do. Or should it be more like there are really more like the base class has nothing in it, and each case really has its completely own separate shape, and maybe they're declared nested inside of the base class, and maybe they're not even like first class types. Maybe you have to, in many functional languages, the cases of the discriminated unions are not types themselves. You just use them to switch your way into which one it is, and the data inside of them gets pulled out for you, but you can't have the thing, the particular shape of it, you can't have that as a first class value. So there are all these like different options on the spectrum. One of the things we have to think about is how well does it fit into C# as it is today? Again, would this have a fairly clean integration story with the rest of the language, as well as we need to gather enough scenarios and say we want to address these scenarios with this feature, and then design based on whether those scenarios feel good in the design that we choose. And so we're not quite there yet with those things. And so while discriminated unions remain on our radar, we don't really know what they are yet. We're going to keep kind of plugging away at that. If you have scenarios where you would like to use them, I would love you to send them my way, because we kind of need some stuff to help us think about this, so that we are solving a problem and not just adding a feature, if you get what I mean. Okay, great question. And that takes us to 525. So what we're going to do is no, it's 525 here. It's a lot later at your end, 8:25, which is when I'm going to hand it back to Sam for closing remarks, and then you're free to leave. Then the talk is officially over. However, I'm going to hang out as long as there are questions and stuff you want to discuss, or comments you have. So I'm going to hang out for half an hour more or so, or until Sam throws us out. But with this, I want to officially say thanks for listening, thanks for the questions, and have a good night.
Thank you, Mads. Highly appreciate it. I just wanted to have a couple wrap-up announcements before we make it a more casual conversation, or call it a night, depending on your preference. So typically, I always mention events that are happening in the area, but since because of the quarantine, everything is happening virtually, which to your advantage, you can attend more than one event. So virtual user group meetings that are going to be happening. The .NET Virtual User Group, you can find their link on meetup.com. And on next Tuesday, September 29th, they're going to have a meeting on Visual Studio and Visual Studio Code Hidden Gems. And the link there is used for registration. On October 15th, which is a Thursday, the Akron AITP User Group is going to be meeting and discussing enterprise architecture in the cloud. On Wednesday, October 21st, the Hudson Software Craftsmanship Group is going to be meeting online, and basically it's about crafting better software. And Steve Smith runs that group, as you recall. On October 22nd, which is the fourth Thursday in October, is going to be the meeting for this group again, and we're going to have Sumit from Microsoft local office, and he's going to be discussing multi-model databases in Azure SQL. And then turning our attention to conferences, this coming Saturday, September 26th, is the Northern Virginia Code Camp. And that is a free all-day code camp running from 9 to 5 with a variety of different topics related to .NET. And I think there's about 4 or 5 different tracks happening. I will be presenting on Blazor at 1 o'clock. So if you'd like to learn about that or any of the other topics, feel free to join that conference. On Saturday, October 3rd, is going to be the SQL Saturday for Memphis. It's going to be happening in Memphis, Tennessee, but taking place virtually. And to register for that, go to SQLSaturday.com, and that is event 1003. And for those of you that are not familiar with SQL Saturday, those are all-day events that take place in basically a variety of different cities all around the world. If you look at the website, you'll see that there's an event happening almost every Saturday of the year in one country or another. And because it's virtually, you can attend it without any hassle. So it is an all-day event of SQL Server related topics. Many of them run 4 to 5 different tracks all day relating to database administration, performance tuning, Power BI platform, variety of different topics, as well as developer related topics, I should mention. So you'll see talks there about Entity Framework and other developer related topics. And last but not least, to round it up, October 24th, SQL Saturday in Oregon. And the link for that is SQLSaturday.com/1000. That is the event number 1000. So if you look in the meetup group under the comments section, you see that I left a comment stating that if you're interested in the recording for today's meeting, you can find it on my YouTube channel. It will be posted in a couple days after I take care of the editing process, as well as the links for events that were discussed now. You'll find those listed on my blog as well. And that link is listed here in the comments section of today's meetup. Should you have any questions afterwards, feel free to reach out to me. My contact information, snasser@nistechnologies.com. And you can also find me on Twitter and LinkedIn. And with that, thank you all for attending, and thanks again to Mads. And so if you'd like to drop off, feel free to do so. If you have any questions for Mads, and Mads, you're going to be sticking around for a few, I take it, correct?
Yes.
All right. So let's take a look at the chat window. And Mads is getting a lot of accolades for a great presentation. Thanks again, Mads. And as far as any questions or comments for Mads? Here's a question from Mitch. Is there any syntax or features you would remove from C# if you could? Interesting question.
That's a great question. Depending on, the answer is yes. and depending on how I feel that day when I get asked that question, I sometimes have different answers. There are obvious things like, well, we added the anonymous delegate syntax in C#2, and then we added lambdas in C#3, and that was kind of dumb to have two. But there are other things where I think that we didn't hit quite the point that we should. And one that I want to bring up is dynamic. I think that when we added dynamic, I think, to be clear, I love the design of dynamic. I think that it has a lot of beauty to it because it makes sure that even as the lookup mechanism moves to the runtime and happens at runtime instead of in the compiler, it still does the same thing. So it works the same way. That's a beautiful concept, but it also makes it's part of what makes it a super expensive feature. We did dynamic at a point in time when we thought that we were building Iron Python and Iron Ruby. We thought that there was going to be this whole ecosystem of static and dynamic .NET languages interoperating a lot with each other. And so dynamic had to be up for that. And also we built it just before smartphones started coming out. And so essentially at a point in time when we still thought that machines were just going to get bigger and stronger every time. So if it was a little slow and a little resource heavy now, give them more slower a couple of years and it'll be fine. Whereas what has actually happened is, and what sort of happened almost, the day after we shipped dynamic, is that devices become smaller and smaller. It actually went the other way, right? Because because the form factors just exploded and the opportunity to run in many smaller things it came about. And so I have some regrets about dynamic and how we did it. It's also like whenever we try to do ahead of time compilation and rely less on the JIT and rely less on reflection for the C# semantics, dynamic is always the sore thumb, right? It's hard to do any pruning of the call tree or the type graph when you have dynamic in the system, because anything might happen, anything might get called, and so it's just it's not worth the trouble. Something like dynamic is good, but it doesn't pay for itself. It doesn't pay for all the pain it's causing. That's my take. That's the one I'll pull out today.
Gotcha. And Leon has a question. He said, you mentioned that C# release frequency is going to be an annual. Is that correct?
That's what we're thinking. I don't know that we'll commit to it really hard just yet. We've committed to it hard with .NET for the foreseeable future. We increase that integral number once a year, boom, in November. That's just the plan for forever and ever until, something big changes. And I think for C#, that could be a good cadence as well. We've been used to thinking about C# versions in terms of a bundle of features that we wanted to get done together, and it doesn't fit so well with that. I think that, but more and more you've seen us put out feature groups more gradually. I think pattern matching is a really good example. It started in C#7 and we got in just the basics. And then we use the relatively frequent releases since then to navigate, to get a feedback loop with the actual usage of the first bits of the feature to do the right things next. And both to choose the right next things to do, but also to do them right with the scenarios that people are already starting to pick up on the feature. And I think having that kind of frequent release cycle and then just getting used to features being strung out over multiple releases, like you're seeing now with records and stuff, I think is a better cadence. We just need to get used to it and thinking about major releases a different way. I think that for us, the 6-month cadence of Java, that feels crazy to me. That's like, maybe we'll get there one day, but I don't think we could get to that frequent releases just now. I think a year feels about right for getting substantial stuff in every time.
Okay.
Let's see. As a student that is 2 weeks into a boot camp for C#.NET of the upcoming feature changes, one of the upcoming features, is there one that you would most recommend I wrap my head around and include in my repertoire? In general, do you have any favorite C# features that may not be included in a beginner level course that you would recommend I explore? Well, so particularly as a beginner, the top level statement should be a slam dunk. Like that's, go pick those up right away. Features that you wouldn't normally run into as a beginner that are awesome. Maybe async, just because there are some really cool things you can do once you're async, and many real world libraries you can only use if you go async. So that, even though it's a fairly advanced concept, you can sort of approach it without understanding all about it right away. And so off the top of my head, that would be one that I would go and try and have some fun with that. You can play with async, just spin up some jobs and some threads, but you can call task.run and give it a lambda with some hard work in it, and you can await the tasks that come out, and you can do your own little orchestration of various things and just play with that to see how async works.
I'd also like to add, as a student, I think it would be wise to focus on the basics of C# and really have a firm handle on that. Reason being, once you enter a job interview, you're going to be questioned on the basics, not so much the newer features in C#. So I would focus more on the underlying foundation, the basics of it, what can be done, what cannot be done, and then expand into the new features as well.
Right. I think that is very spot on. But I just want to say one thing, that a lot of people think that the basics of C# are C#1, like start with C#1 and move on. But I would really encourage you to pick up a very recent beginner's course, right? Get someone who shows you, because C# has evolved historically, but not necessarily by layering more complex stuff on top of the simple stuff. In many cases, the way you would do things in C#1 is much more complicated and much more annoying and much less helpful and useful than the one you would use in C#9. So, so the beginner's course in C#9 will include some fairly recent things, and it will certainly include, every example will be in top-level statements for sure. Just to start with that. So, so yeah, I think just eliminating that confusion between what is basic C# and what is early C# is very important. That's not the same thing. We try to make it easier sometimes, and sometimes we even succeed. So, yeah. But
speaking of basics of C#, why is it that you can only inherit one class? When is the plan to change that? And why was that even in there to begin with, since Java doesn't allow or allows you multiple inheritance?
Java doesn't allow you multiple inheritance either.
Sorry, C++ rather.
C++ does, and it's a mess. It's highly confusing. There are several reasons why multiple inheritance is very difficult. I mean, I'm all for it in principle. It makes sense. You can, if you think about object-oriented programming as conceptual modeling, right? Of course, it makes sense that you can inherit from more than one other concept. It's just, it seems very natural. And you can with interfaces, but when it comes to implementation, you don't get to. And it's because it's for technical reasons, but they're pretty hard ones, like how do you combine your construction logic? All the hard things about multiple inheritance, you get those diamond scenarios. You have two classes that inherit from one base class, and then you inherit from those two classes. Now, how do you do construction of in that most derived class, right? You want to call the constructor on one side, and then you want to call the constructor on the other side. But that's also not good enough, because now both of those are going to call the constructor on that they inherit, and then that's going to be run twice, and that might have disastrous effects. And so the whole ordering of constructor logic, when constructors are chained, that just breaks down. You need a different metaphor for construction even. That's just one example of how these diamond problems, how these fork join inheritance scenarios are extremely confounding. And they grind up against the very sequentiality of code, right? You have a chain of inheritance that dictates a chain of code that gets called. Like methods want to call the base class, they want to call base, or super in Java. And what does that mean when you call more than one, you have more than one base, and how does that combine further up and so on? It's just a mess. So
makes sense now to explain it.
So I would love for us to have such advanced understanding and such an advanced form of programming that this ceases to be a problem. Like if we could get rid of sequentiality, if the fact that one thing happens after another in a program became an opt-in rather than the default. If you could say that everything's parallel, and all the initialization happens at once, and you just express your dependencies, and you get only the ordering of events that you ask for, then maybe you can imagine, that these things go away. But that's like, that's what that's the kind of thing I was vaguely dreaming of when I was a PhD student, but I could never figure out how that would work out in practice, and nobody really has. It's just like, we're not really there yet. That's a great question.
Thanks. All right.
But,
any other questions from the general audience?
will features that were awkward to implement in the compiler, like async, eventually be migrated to the runtime? Ooh, that's a really good question, because we're actually, that's a question for debate. Now that we can, should we go back and fix some of our mistakes? It's really hard because of already compiled artifacts, and so if we change the way something compiled on one side of an assembly boundary, would that completely break the other side? That's the most difficult. That's sort of the legacy question of it. And I don't think we've built up the courage to say, darn it, we're gonna start over and people have to recompile. We're not there yet. Maybe one day. But that said, we've actually had some investigations into things we can do that around the async state machine, so that we can implement it more efficiently in a way that's backwards compatible. So we have had some initial investigations on that, and I think we're going to push on some of those things where we can, without changing everything, we can do additional smarts in the runtime, or maybe through some combination of, when the compiler puts in extra hints, the runtime understands them, then it can take this faster path than what was generated into the source. Unfortunately, those approaches mean that when the original compiler approach gave rise to a fair amount of code bloat, then we still need to leave the code bloat in case the consumer isn't the new kind of runtime that can do the better, smarter thing. But it's on the radar. It's hard to approach, and we don't have a systematic commitment or approach to it, really. We're trying to look for low-hanging fruit, but we are starting to look, and it might, for async, it might lead to some fairly decent optimizations. Since backwards compatibility is important, what do you verify against to be confident you haven't broken something in an older version? Do you have some crusty old C# code that you dust off for the compatibility check? Yeah, in a manner of speaking, we do. So you think this is a big question, version to version. You should try to build a completely new C# compiler for C#6 that is bug for bug compatible with the one that we use for C#5, which is what we did. So we, between C#5 and C#6, we built a completely new C# compiler that's called Roslyn, and that's unlike the old one, which was in C++. This one is in C#. It has a full public API, immutable, as I talked about, elegant. You can do anything with code with it. It's beautiful and keeps evolving, and it's excellent. And it has to compile C# in exactly the same way as the old one, even when the old one was wrong, because it could be wrong in a way that people depended on, and the way we would now break their code by giving them a new compiler. And they would never, like, the rollout of the Roslyn compiler would have failed if we weren't bug for bug compatible to the highest degree we could possibly ensure. And the way we ensured it was we gathered up insane amounts of regression tests for all kinds of things in the language, both like tests that were created for the purpose and old pieces of code and all kinds of things. And we run those as part of our CI, and we just do a large amount of regression testing, which goes both for the compat aspect and actually also for the performance of the compiler. We also have So related to this, one way we don't want to regress is we don't want the compiler to become slower on existing code, or either on batch compile, or since it's the same code base we use, or in tooling scenarios. So we also run all these automation scenarios where we simulate tooling, you know, calling into the compiler API and doing hard and difficult things, and we measure how long it takes, and we compare old and new, and if there's a regression, we flag it, and somebody goes and investigates. Ooh, it looks like adding this new refactoring made the whole thing slower. You know, what's wrong, and can we fix it? And so we have some of the strongest regression testing for both functionality and performance that you find anywhere. And that also helps us when we add new features. We break something, we will know.
So when you say you have an insane amount of tests for regression testing, how insane is this?
I don't even know the numbers anymore. I'm sorry. It's been we should call in one of the compiler folks. I mean, it's probably in the hundreds of thousands of tests. But I don't want to put my head on the chopping block on that. I'm just happy it's there, and we keep adding to it also. I mean, it's whenever we break something, obviously that becomes not just one, but probably like 100 new tests to make sure we don't do it again in any shape or form.
Makes sense.
So it was, I mean, to be clear, the Rosling project building that new compiler was several engineers, like leading up to, you know, tens of engineers towards the end, or at least over 10 engineers for like a 6-year period. It was a massive undertaking, and a lot of that was building an infrastructure that allowed us to trust what we did, which we didn't really have before. I mean, we did have some tests, but it was much more like hit and miss. So, yeah. Great questions.
I got one more while we're waiting for others to chime in. What kind of interview questions do you ask potential employees that are coming onto your team? Assuming they have not already been hired by Microsoft and they're not transitioning, but rather they're coming directly onto your team.
So I wouldn't tell you. No, honestly, they don't. I'm way too soft of a person, so I rarely get put on interview loops to assess someone's technical skills. Also because I'm not a developer myself. I'm a PM. I mean, I can write code because I'm a PM for something that has to do with code, but I'm probably not the right one to evaluate whether someone would be a good dev. So what I'm typically, when I'm put on an interview loop, and it's not that often, it's typically it's more for people to ask me things than the other way around. Sometimes I'm the lunch guy, or I'm someone that can have a more free-form discussion. So I'm not usually one of those people who is like, you know, interrogating people about their coding skills and driving them around, you know, driving them up the wall with harder and harder requirements on that. I don't have the personality for it, and I don't like being mean to people. So
understandable.
That's rarely me, but I mean, to be clear, other people do that, even though I'm not. We're trying to become a little more, or actually a lot more open in our interviewing process, because we found that, and that goes more for the PM side than the dev side. We found that we've been focusing too narrowly on technical skills traditionally, and we would end up getting a fairly narrow slice of the potential talent out there, actually narrow to the point where the set of perspectives and the sort of diversity was not high enough in the PM team traditionally. So we've been really doubling down at thinking more holistically about hiring and about skill sets that that are valuable for PM, and trying to tailor our interview process to that, because at the end of the day, PM is that's the discipline that sort of represents the customer in the organization. That's a discipline that says not that we're doing the things right, but that we're doing the right things, right? And if we're too narrow or too similar as representatives of the customers, we are making wrong decisions. I find that we're all the broader and more diverse we've become in both sort of background and skill sets and so on. The more the broader perspective we take on things, I find that we really make better decisions as an organization. We take many more things into account. We're much better able to connect with broader sets of customers, and just holistically, we do a much better job. So that starts with the hiring and the significant change of profile that you see in or sort of average profile and diversity you see, particularly in PM, but also on the dev side.
Okay. All right, it's now 5 till 9. One more question. Are there any new C# features that came about from development on Maui?
Well, we're not done with Maui yet. I suspect that it will probably drive a few C# features, depending on how Maui turns out. I think Maui is now slated for .NET 6. It got delayed because of COVID and being tight already. We sort of said, okay, let's take a reset and target Maui to .NET 6. And for those who don't know, Maui is the idea that we will have a shared user interface, a shared UI framework across .NET and across form factors. So it's sort of like, think of it as Xamarin Forms Deluxe, something like that. But one of the things that's being discussed for Maui is for it to have a not just a code first approach, which is sort of like a return to WinForms in a way, but also one that is based on a model view update metaphor, which is similar to React and things like that, where you essentially on every update cycle you build a fresh logical representation of the UI tree, and so you have a data structure that's your logical view, your logical screen, if you will, and then it gets rendered by diffing and sending the necessary updates to the physical, whatever physical layer is presenting your UI. So that has become a fairly popular model. It actually lends itself well to some of the immutability stuff. You want to do the same as before, but with this thing changed, so I can imagine a lot of use of width in mutating without mutating the graph, non-destructively mutating. But it also leads to, like, you have to create this tree, this UI tree, and that's sort of like a lot of nested creation, new this, new that. And I think besides the target type new, which I think is useful there, I think we can probably think of a few more features that will make that a more pleasant experience to be creating these data structures with less boilerplate. And we have already talked to the Maui team some about what those things could be. But I think that's where I'm imagining that most of it will be around that creation, that initial creation and initialization of the tree, which you can see is it's fairly well connected to a lot of the stuff I've been talking about today thematically, about how can you best describe a complex object graph that gets created anew.
Okay. Any other questions for Mads? Going once. Going twice. All right, I think we're nearing everybody's bedtime here on the East Coast, so.
Y'all can go have drinks and I will go and have dinner.
Sounds good. Thanks again. Highly appreciate it. And
Thank you so much. Such
look
a
forward
pleasure.
to having you present again in the future, hopefully.
Yeah, I've just got to invent some more stuff first, and then I'll be back.
Details.
Thanks so much for the opportunity. I really appreciate it.
All right. Thank you. Good night, everyone.
Good night.